I'm Tony. Let's just jump right into, blue sky. The number one trick that all senior developers know and follow. What? Oh. It depends. So if anyone who's trying to be a senior developer, someone asks you a question, you're like, it depends. Especially in C++. Like other languages, it seems like, Java, I don't admit this, but I did write Java once upon a time. And you just follow the pattern. You're like, oh, you use a hash map. Like that's the way you do it. And you're like, C++ is like, well, no, in this case, it's always the right answer is it depends. So, should I check for null here? Yes, thank you. All right. Good. We're done. All right, here's the story. A long time ago in a galaxy far, far away. So a long time ago is 2 years. This galaxy travels 25 billion kilometers a year. So 2 years ago, 50 billion kilometers away. That's a far away galaxy. It's this one, but it's far away. 2 years ago, a co-op student asked, the intern, if you don't know what a co-op student is, asked simple question, basically, should I check for null here? It was very first check-in, just trying to do some feature or something, and then they're like, oh, should I check for null? And I can tell you exactly, of course, obviously, you should check for null here. You should always check for null. And obviously, you should never, ever check for null, right? Whoa. Oh, there's a big blurry text there that is so blurred you can't even see it. Yeah, there's just like, so, visuals. This is my reply to them, and it goes down to the bottom. But I blurred it out because it wasn't, And then there's a couple spots where it's like, I said there's two things here that you need to, two possibilities here, 1, 2, and 3, because you always got to have the off by 1 error. Like, just get them used to that. What's the 2 hardest problems in computer science? Naming, cache coherency, and off by 1 errors, and progress bars. All right, and the bottom of it said, that's the short version. For the full version, come see my talk about contracts, which didn't exist till a couple hours ago, till last night or last few days. So yeah, this is it. You're going to finally answer the question. So why should we check for null? Why shouldn't we check for null? Anyone want to? Just because that's what we do. There was the other comment. The first comment I had in the check-in was, when in Rome. Like, if this is a company where we check for null, then I guess we're checking for null, And if it's not, then we don't. Any? Yeah. That'd be great. Construct it so it can't be null. Like, just avoid this state at all, which gets into a whole conversation about exceptions, in my opinion. Right? Because everything else you can return values, return an error or something, but like I'm constructing an object, if it can't be constructed, my option is throw an exception, right? Someone over there. Yeah. Yep. Yeah. Yeah. Okay, null is valid maybe, and don't trust the caller. Let's see what I got. I got, how about we don't crash? That's I don't like crashing. I don't like undefined behavior. Robust, I will explain that in a minute. And then there's these other things like it's viral. Once you start checking for null, you're going to be checking for null everywhere, right? It's like, oh, null is a thing I have to check for. And then the part of, is it a bug, right? Maybe null is a thing. And once you start having lots of nulls, then null is a thing, right? And I'll explain some of these. So don't crash. Like that's the obvious one, right? I've got this code. This is what kind of what the code looked like. And it wasn't even a pointer being passed in. It was an internal pointer. And it's like, check if the internal pointer is null, which is exactly like, why did you construct this thing? Like it was I was working at a projector company. We did projections and cameras and stuff, and it's a device. And the camera device has a like abstract device pointer, blah, blah, blah. You don't really have a device if you don't have this underlying pointer that goes to the real hardware. So like, why do you have this object at all if you don't have the internal pointer? But I'm going to check for null so I don't crash. But that's only one type of undefined behavior. Crashing is kind of a better undefined behavior if you could rely on it to crash. But you get stuff like this. This isn't going to crash. It's just going to give you the wrong value, right? If you didn't check for it, if you just were out of bounds, right? Maybe it crashes depending on your OS. Maybe whether the memory is there or not. How far off are you going off the buffer? Or you've just put in a security exploit. Drive a big truck through it, right? So I'd like to avoid that. So maybe I'm going to check for stuff like not just null, but other things. So it depends. What did I want to say there? I'm missing something. Oh, yeah. So it could be costly, right? You could be a security violation. It could be deadly to not check. Like crashing is usually not as deadly as getting the wrong value. The wrong value can kill people. Crashing, depending on your situation, can also kill people. Or it could just be, the wrong value is fine. Like I worked at Adobe Premiere, a bunch of Adobe products. It wasn't life and death. It was like, you're editing video. The wrong value is not going to kill you, right? So it depends whether the wrong value is a big deal or not, actually. But what do I want to say? Undefined behavior is, I would say, worse than crashing. I guess I've already said that. So what about being robust? I kind of mentioned this already. So here's my little timeline of, I worked at a place called Inscriber in the television industry for like 9.5 years. I worked at Adobe, which actually that was like a joint venture that ended me up from Inscriber to Adobe for 9.5 years. BlackBerry was 6 years. Christie was 9.5 years. So I don't know what I'm doing yet. That was like 2 weeks ago. I'm done at Christie. If you want to talk to me after. But there's a lot of Adobe in this talk. I don't know if Adobe wants me to tell you about it, but that was like 20 years ago. It's actually, a lot of it's changed because I still know people there. We had a chunk of Adobe code in the Adobe Premiere video editing, worked on like doing the title graphics and stuff like that. That code checked for null everywhere, checked everything. It just was paranoid, it checked for everything. And it's like, is that good or bad? But one of the things that was kind of interesting was that one, it just never crashed. I mean, it probably still did, actually. Yeah, it still did. But, it didn't crash very often. And it was kind of cool that if you're trying to figure out what's going wrong with some part of the system, you can just shut off other parts. It's just like, oh, I don't need the spell checker. Set it to null. Oh, there's no spell checker. Does the code suddenly crash? It's like, no. It keeps going. If you're looking for like a memory leak or something, you just start shutting pieces off and the rest of the thing would just kind of hobble along. Is that a good user experience? No, but for debugging, it was actually kind of cool, right? So spelunking for bugs, it was kind of nice that I could just randomly set things to null and keep going. Maybe that's not what you usually want to do, but sorry. Let's just think. We'll come back to some of that. So those are kind of the goodish things about checking for null. Here's some of the bad things, right? If you check for null here, you're probably going to check for null there, and you're probably going to check for null there, and then eventually you're like, oh, at this code base, we check for null everywhere, and it's just kind of viral. You start thinking, I guess this is what we do. So everybody checks for null. don't know why I need that there. Well, maybe I should look at my own slides. Oh yeah, if you check for null here, you're going to check for null there, and what about there? You're going to check for null everywhere, right? And then it just becomes noise. It's like, I want to look at what this function really does. I don't want this preamble of like, oh yeah, check for null, do this, do this. Oh, here's the real code, right? I would rather just not have to think about that state at all, the null state. And then you get to the point of, is it actually a bug? At some point you're like, if I'm new to this code base, I see it checks for null everywhere. I'm like, I guess this thing is null sometimes. And then you start looking through the code and it's like, when is it ever null? It's never null. And then this actual, at the beginning there of like, co-op asked, should I check for null? We're like, no, it's never null. Then she's like, yeah, it is in tests. Like, it's null in these tests. It's like, oh, well, you should check for null then. It's like, but none of the other code checked for null. And we're like, oh, how does this work at all? But, you know, at some point you start believing that null is a fine value. And then at one point it was a bug, but we wanted to be safe. But now it's like, maybe it's okay. And then eventually someone is going to assume that null is okay, and it'll become, yeah, null is a thing that happens in our code. And then you have to stop reasoning about, oh, I thought null was never valid. Like you're looking at, what happened here? Is this null? Oh, that never happens. Oh, no, wait, it does, because we let that creep into our code base. So if your code looks like this, then you know that null is a bug. Like there's no doubt. This code should never have null. I know if I'm doing a code review, I'm like, hey, your thing could be null here. It's obviously wrong. Like, I know it's wrong. Same with this kind of thing, right? If you see someone access an uninitialized int x, that's got a bug. Like, you don't have to question. If this was a string, you would question, it's like, oh, did you meant for the string to be empty at the beginning? But this isn't x isn't 0. It's just, oh, I don't know. It's just whatever value. So you can look at this code and say, I know 100% that this is a bug, right? Even if it runs fine and it happens to work. And another great Adobe story. We were working on Adobe Premiere, and we were just about to release the new version, and Microsoft called us and said, hey, with the new version of Windows, your old Premiere crashes, all right? And we're like, oh, man, we don't want to fix that. Like, we're like a couple of weeks away from the new version. We don't want to go back and fix that. And they're like, it's okay, we already fixed it. We're like, what? Like, yeah, it's uninitialized variable on the stack. We'll take care of it for you. We're like, how do you? When you start up a program, when you run Windows, you start up any program, it checks, wait, is this Premiere? Because I have to put in the, you know. But that's what Windows does. It does it for like just a whole list of programs where it's like, hey, this, like, I mean, that was probably the stack randomization or something like that. Like, don't do stack randomization on Premiere, otherwise it'll crash. Because Microsoft, knowingly, they'll get blamed. It was our fault, but they would get blamed for it. So they're like, we've taken care of that for you. Because we had that. We had an uninitialized variable. This is now called, starting in C++ 26, this is called erroneous behavior. In 26, if I got this right, I think I got this right, x will have a value. It won't be like, God, I wonder what's going to happen. It won't be a source of security vulnerability. X will always have the same variable or the same value every time you run it. And like, you know, messing with the stack or new version of Windows isn't going to change it. It'll always have the same value. What is that value? None of your business. It's still an error to use it. We didn't want to lose the fact that I can look at this code and see this is wrong. If we said, I mean, the committee, because this was undefined behavior, we could have just said, well, starting 26, this is 0. Just, why not? Like, strings get initialized. Why doesn't ints get initialized? Just call the constructor. And people are like, no, I want to know that this is an error. I don't want to lose. I want to look at this code in the future and go, did they mean 0 here? I can't tell, right? Kate has a talk on what do you say when you say nothing at all, right? The code doesn't tell you. Like, you're supposed to make assumptions. So the committee is like, we don't want it to be a source of security issues. We want it to have a value, but we want it to still be an error. So it's got a value. None of your business what value it is, right? And I think it's like implementation, technically probably implementation define, what value, blah, 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 blah. And it's 0. It's probably going to be 0. Yeah, I mean, maybe it's a compiler flag, like who, implementation, do what you want. But now, if you got this case, it's like, I don't know if this is supposed to be an error or not, right? So that's an increased cognitive load of like, I can't tell bugs from non-bugs. So on top of that, what am I going to do if it is null? If I'm going to handle that, I got to return something. I got to do something. I got to, what am I going to do? Do I actually explain what I'm going to do? I should maybe not ask the question if I don't have the next slide. I don't have the next slide. We're going to come back to what we're going to do. But, that's an extra cognitive load. Oh, I got to think about what to do when it is null, right? And for every function, it might be different. Oh, in this case, throwing is a good thing. In this case, just return 0. It'll be fine, right? It's like, it was asking like how many widgets in the thing. There is no thing? I guess there's 0 widgets, right? Like, that could be a valid value. Then you're like, oh, maybe they divide by 0. Let's just return 1. That's safer. Let's return 17. Like, sometimes like you can look at, you realize there's a bug there, and you look at what the code used to be doing, and it's like, oh yeah, this code would fall through the cracks and return 17. I guess that's a good number. Like, and then when you return, you are saying like, I know null is a bug, but I'm going to return a value, and I trust that code above me to do the right thing. You know the code above you has an error. You know it has a bug. Why do you trust anything? The whole program question, there's like, you don't know the state of your program. So you should maybe do something else, right? Just like stop, just like, whoa, let's get out of here, right? And a lot of like high-tech finance, stuff like that, it's like, hey, why don't you turn the wrong value and we'll like make $1 billion trade accidentally. Oh no, we don't want to do that. Or heart monitor or some kind of medical thing. It's like, then you're like, well, terminating and crashing. Terminate sounds really bad when you're talking about hearts. Like, doesn't sound good. But it's like, no, all those things will have terminate it and it'll start up another one. And so you're just in a fresh state. And hopefully it starts up fast enough that, everything works out. But I did, going back to Adobe again, I did look at bugs at Adobe as a little side project. Every time someone checked in a piece of code that said, fix the bug. It's like, okay, I don't want to see your fix. I want to see what bugs look like. Like, we all did, we should assume that there's bugs in programs. They're all over the place, but it's like, what do they look like? And actually, all the time, yeah, just go up a couple of layers back. Everything's fine. Like, it's just almost always the whole program's not in this terrible state of like, I don't know what's going on. It's like, nah, this little corner's back up a little bit. Everything's fine. In the product I was working on, at least. But it is philosophically, why would you trust the program state when you know there's a bug? You know that you got something wrong, so everything's probably wrong. And then like, in this case, I was saying, this is like inside the projector class, for example, there's this abstract device. Why have a projector without this device pointer? Like, now I've got this class with partial state. Right? That's what we talked about. It's like, I don't want this class to ever have partial state. It's either exists or it doesn't exist. So probably the thing to do is throw in the constructor if you couldn't make that device pointer for some reason. Except for move from values, right? Move from values are these things, I love move from. Like, I love it. It's one of the best features. I can go to my other talks where I can return, you can now return a vector. I mean, you could kind of return value optimization and everything, but now it's like, I have functions that return values. Those values are huge, but I know it gets moved, or return value optimization, and all this stuff's guaranteed now and stuff. It's like, I love it. But then, if I have my projector class gets moved, do I just leave it in this half state where it's like, that's when the device is null? Because I know it's probably just going to get destroyed or something. But it's like, I don't want that partial state in my program at all, but I want moved. I want move semantics. I love move semantics. If only there was a language that... Anyhow, these are some of the it depends of... Is that the next slide? Yeah, I guessed correctly. So, error handling. Not just bugs, but like error handling in general. Because maybe this null pointer was a bug, maybe it wasn't. Maybe null wasn't a bug, maybe it's just an error that you expected. What do we mean by errors and who? Who do we mean by errors? Why is Gomorrah? So what? So there's good definitions out there. The function didn't succeed. It didn't do what you wanted. Like there was a happy path of this function or the program and file not found, something went wrong. That's an error, right? That could be a bug, could not be a bug, but there's something's wrong in general. Right? User input, file not found, something went wrong. And you can break these up between the ones you expected and the ones you didn't expect, right? The expected errors are, you know that the user is going to give you the wrong file name, or you know that these things happen. You know I mean, do we really run on a memory nowadays? But, you know, actually a lot of Adobe products still run on a memory because you can like try to load a gigantic image or something. So it's one of the few things, and there's like, no, handle, you know, we don't check for, I couldn't create this tiny class of 80 bytes. You know, you're screwed in that case. But like, oh, I tried to allocate a 100 gig image. Didn't have memory. But there's certain errors you expect to happen in your program, and then there's the unexpected errors, right? Those are the bugs, because you didn't expect these. You didn't write code for these, is what it really means. Bugs. So, who? Here's some function, something bad. You know, we checked, we found some kind of error, we checked for something, we think something bad has happened. Who are we going to report this to? Give you 4 choices, 4 guesses. Who do you, like, what kind of, like, where, what are we going to do? Got to tell somebody there's an error. The caller. Man, you guys are so good. Right? So if something normal bad happens, let's just tell the caller. It's like, look, the file, there ain't no file. I don't know what you're talking about. You know, return it. And you expect the calling code to handle it, because in your you know, documentation for the function or something. Documentation for the function. You know, because people looked at your code, figured out what it does, they should know that it returns an error in this case. So the calling code should handle it. You know, what are we going to return? Like maybe we return some kind of just an error value, -1, and you document that -1 means do the thing. Or, you know, something better than -1, like an enum or something like that. So obviously suddenly not valid C++. I'm just getting, like, these are all one or the other, right? Standard null op. Maybe your function returns an optional, and so you can say, that thing you wanted ain't got one. Deal with it, right? Well, we could return standard unexpected because your function is going to return a standard expected. And that's new. People don't know standard expected. It's halfway between optional and variant. It's like, I expect a string coming back from this function. But if not, here's an excuse why I couldn't give you a string. Right? Do I even have a slide for that? Yeah, standard expected looks like that. You know, he's like, here's a string, and the excuse can be anything. Excuse can be a bigger struct than what you're actually trying to return. And expected is like variant. It's big enough to hold one or the other, right? And a flag saying which one it is. So then it forces you, the caller, to be like, oh, I get a standard expected back. And it doesn't quite force you. You could just go, I assume the thing is there, but like I told you, yeah, you should expect the string, but maybe not, right? Oh, what a name. Standard expected. Didn't I just say like bugs are unexpected? And so this is different word of expected. Standard expected is you expect the good value. Maybe it should have been called something else. the excuse shouldn't be unexpected. It's just not typical. Should have been standard typical or something. Or, you know, I should use different words here, like the planned bugs, the normal bugs, the unplanned, the abnormal bugs, the planned errors and the normal errors versus the unplanned and abnormal errors, which are called bugs. Okay, anyhow, you could return a standard expected. You could throw an exception. You could do whatever, stuff like that. And it all goes back to the calling code, right? And then you're like, the calling code will deal with it. Who else? It depends, right? You can. I don't want to figure out which one. Oh, I don't like exceptions. I don't like this. I love doing whatever. I love optional. I hate optional. Optional ref. Blah blah blah. It depends. That's always the answer of which one of these things should I use. It depends. But you have lots of options. So, what about when it's not a normal error, but it's a bug? Do we expect the calling code to handle it? No, like it's not supposed to happen. Why would you write code? Like, to a certain extent, you could be like, well, I know we have bugs in our code. I should write code to deal with the bugs in our code. But you're just going to write more bugs. I don't know. Let me guess at what the bugs are going to be. Why don't you just fix them if you know what the bugs are going to be? So who do we talk to? Who do we want to talk to when you detect a bug? Yeah. Wait, come on. Yeah, right? You want to talk to not the code. You want to talk to the person who wrote the code, right? The only way to fix this error is change the code. So you need to talk to the calling developer. It's not, you don't really have to talk to a developer anymore. You could just, every time you run into an error, try again. Hey, somebody, some AI. That was on the internet, I'm sorry. All right, so how do we talk to the calling developer? We email them, right? That's probably not going to work, right? Be great. We could log. That's a normal thing to do. We might log the other errors too, but log for the purpose of hopefully this gets back to the developer. We can terminate. Just be like, maybe after logging. I guess these are not ORs yet because you could log and terminate. Standard logic error, which we love talking about in the committee because it's the same thing. It's like, hey, there's logic error. Let's throw that up to the person who has the logic error and tell them you have a logic error. And you should write, well, no, my code is not logical. Why? How do I deal with the logic error? So standard logic error is illogical. But I do have code that throws, actually it's a little habit of mine where I'll throw standard logic error and then in the string quotes, I'll just quote some song. It's like, this is not my beautiful house, because it seems appropriate of like, I don't know what's going on here. This is not my automobile, whatever that, talking head song. Because I really am hoping that will never propagate to the user. Like, it'll get caught before. And if it does, well, I'm not writing, or wasn't writing, life or death code or anything. So when at Christie, it's one of the few times, usually I write code that is being run by the public. At Christie, I wrote code that's being run by other Christie people that set up the projectors and everything. So it's like, I can make the comments be whatever I want. Didn't really matter. It was kind of fun. And you could do all the other things. You could do the return values, but you're not probably getting it to the developer, but you still have to do something, so you could do all these things, Or, this is a weird one, you could return a non-error value. You're like, I know you're not going to handle if I return -1, because why would you? Because I only return -1 when it's a bug or something. So I'm just going to return a default value, and maybe everything will be okay. Premiere had this where we had all these checks for errors, right? Had these macros that would check this is valid input or not. And one of them was on the file open function, it would say, hey, are you giving me a valid file name? Like, I'm not even going to try to open it if you're not giving me a valid file name. That's a programmer error, right? And then you go look at the valid file name code, and it's like, every OS has different valid file name. It just checked for empty. It's just like, empty is not a valid file name. That's all we know, right? And honestly, 9 times that thing fired off. 9 different occasions we had bugs reported to Premiere of, hey, Premiere, and like it would do this. I'll show you later, I think. I'm skipping around a little bit. It would do this thing where it put up a big dialogue saying, oh, bad thing happened, blah, blah, blah. And all 9 of those, if you had just let the file name go through, it would try to open the file, file open would fail, and the program would be like, oh, I couldn't open the file because the user gave me null or whatever reason. It was null. It was empty. Like, we were overzealous of the check. And that was a case where, like, a default value would have been fine. It would have just smoothly kept going along its way, and everyone would have been happy. But again, I should have a slide. Next slide should say it depends. It depends on your situation. Okay, who else might we want to tell if something abnormal happens? And I passed in a this pointer this time. The other way around. It's the function author, which might not be the same as the function, the person calling you. Those are 2 different developers. Especially if you work, like I worked at BlackBerry, we worked on the OS, and I wrote OS APIs, right? So I really wanted a different error mechanism if it was my fault. It's like, oh my God, internally, things are screwed. It's not that you passed me something bad, it's just like, I don't know what's going on. We need to get out of here. If you pass me something bad, I'm just like, that's your fault, and I'll push it back to you. But if I find something's bad internally, then that's worse, right? It's like the OS is in trouble, It's not even the OS, I wasn't that far down, but like the graphics of this exe is in trouble or something like that. But, same thing. You want to email the function author. You want to do all the same things that you do for the calling developer, but it's slightly different. Like you might, because it depends, you might have a different mechanism for the calling code as for the library code. You might make different decisions. Oh yeah, there it is. It depends. And again, it's the same thing. Either way, someone needs to change their code, but it's just who's changing their code. If it's a bug, somebody's wrong, point some fingers, figure it out. All right, who else do we need to tell when something bad happens? Yeah, the user, right? Whether it's an expected thing or an unexpected thing, you're going to tell the user. Sometimes you tell the user by crashing. You just it's kind of rude, but it's a thing you could do. Sometimes you tell the user by like passing back bogus values and hoping the thing hobbles along, and then the user starts going, oh, this is weird. Things aren't working right. Lots of ways to tell the user, put up a message. But in all cases, you can't avoid it. You're going to tell the user something. So expected stuff, you want to tell the calling code because it expects it to happen. Expected errors. Unexpected stuff, you want to tell a developer. And in all cases, you want to tell the end user. Wow. Oh yeah, here it is. This is what Premiere did. If we detected a bug, like we've done something wrong internally in Premiere, we put up this dialogue. This is called panic save. Okay, it wasn't this dialogue. It's this dialogue. It's, hey, sorry, a bad thing happened. But it was really cool because we detect it, and bad thing happened, and we're like, don't save the document on top of their existing file. Just put it over here. Write a note to yourself saying, bad thing happened, saved it. tell the user, bad things happen, we're going to, and then you know, close. You say, when you restarted, it would be like, there's that file on the side. Oh, we must have crashed. Then we tell the user, hey, we've got your doc that we didn't touch, and we got this other thing. Hope one of them is, you just, you know, here you go. You know, sadly, it took us years after I left Adobe. Someone's like, can we just do autosave? Like, just autosave. And it still does this, but the delta of what you may have lost is just tiny. Like, no one cares about this anymore. But it really was called panic save, not spelled like that. But and it had like, at the beginning of the program, we allocated like megs of memory, so that like if you're in panic save mode, you free that memory so that you have enough memory to like put up the dialogue and like all this stuff. It had so much stuff to be like, can we just survive long enough to put this dialogue up and then close? And then the question with that too is, when you detect an error, do you try to get to this dialogue straight? Just like wherever we are right now, call that function, just panic save. Premiere actually went the other way, and it's like, throw an exception that we don't expect anyone to catch, go all the way to the top and go, ooh, that's the bad exception. Okay, let's get out of here. And it's that same thing of like, why do you go back if you don't trust that code back there? And then the other hand, it's like, yeah, if you look at the code, that's usually it's fine. But the other part of it is, as you go back up the stack, it unlocks stuff. And maybe you can actually save now. Because when you're here, you might not be able to save the document at all because there's a lock on the document or things like that. You can just deadlock. They've actually switched it around now. I don't know why, because I was talking to somebody who's like, oh yeah, we just go straight to panic save now. We don't go backwards. But I should have a slide that says it depends. If only I made one of those. Oh, and the Adobe one was using these macros. We had macros for like, this function requires, and we called them contract macros. Just a little foreshadowing. So, back to that question of, is it a bug, and how do you know if it's a bug, right? So, something happened, is it a bug? You check the docs. Those docs that don't exist, right? But like ideally, you check the docs on the function and it tells you this thing doesn't want like null or whatever. What's this one? You know, X has to be greater than 0. Pointer's not null. You know, just check the docs, and if it's that, then you know you're doing a bug. It's clear because someone told you. Or you know, you check the code because there's no docs, right? Hopefully, there's docs. Also, the, requires thing to be valid. What is thing? What is thing in this sentence? You know, like, is it a global, or is it like it used to be passed in, it just doesn't exist anymore? Like, is the comment old? Is the comment out of date? Or, and what does valid mean? It's kind of questionable if that documentation is even correct. All right, there we are, contracts. Wouldn't it be great if there was a better way? All right, so that comment is a contract, right? It's like, hey, this is the agreement between the caller and the function that you got to do this, and it's actually two contracts, like X is greater than 0, pointer not equal null. That's another contract. The function does this thing. That's also a contract. That's what the function is going to do for you, right? That's part of the contract of the function. And, whatever, the return value, blah, 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 blah. That's would also be a contract saying what the function does. Highest prime, less than X. I don't know why that does that, but, had to think of something. So what's bad about contracts when it's written in comments, right? It's not parsed. It's parsed by humans, but like I mentioned, it falls out of sync with the code. Surprisingly, I started putting down a list of like, what's bad about it? And like, it's just that it's not parsed. This is the only thing that's bad about it. But that leads to a bunch of things that are bad, that it falls out of sync. And you kind of, as we'll see, it limits other things you might be able to do, right? So, what about C++26 contracts? It's now code. You just write all that stuff, and it's now code. And it stays in sync because the compiler is going to look. And I guess in this case, thing must have been a global variable. Thing has to exist, otherwise this doesn't compile. The compiler has to be like, I know what you're talking about. I know these variables. And you can even talk about the return value variable by giving it a name. In the post is a precondition, post is a postcondition. Hopefully most of you went to the talk earlier. And I think it's so beautiful you just understand. I don't have to explain it. There's nothing questionable about the contracts proposal. But really, like, so far, like, that's, that all makes sense. I think if you see the post r colon blah, what's the r? It's the return value of the function. You just gave it a little name, a little alias right there. That's kind of cool. So, but what's it actually do? Like, okay, now it's in code, but what's it do? Good job. Okay. Before we could like email the function author and log and terminate. And if I skipped it earlier, like very clearly, we're only talking about the unexpected bugs, right? Now in contracts. So it's the case of like email the calling developer, email the function author. What you can't do is return things from this function, right? You're not inside the function and saying, oh, well, in this case, I want to return 0 so that the code continues or something. You can't do that. But what you can actually do is return whatever the handler wants, because there's going to be this handler that handles things. Why can't you return? Oh, there's a stray checkbox. There can be only one. How old is the audience? Come on. All right. You can have one contract handler, right? It can't decide, oh, if it's a contract failure in this function, I should convince that function to return 0. Oh, if it's a contract failure over here, I should return an empty string. Like, how would you, even if I don't even know if it's a good idea, but how would you even do it? The language isn't set up for that. Return a standard any from the handler and hope it does the right thing. I don't know. Just doesn't seem like good. So we can't. I just went away for a second there. Can't modify the return value of the function, but you can do a bunch of other stuff. You can also do nothing. That's a good option. I like that. So this was probably somewhat in the last talk a little while ago, but here's what you can do. The ignore contract does absolutely nothing. It does one thing. It still compiles it. X still has to be valid. Thing still has to be valid. All that code has to be valid code, but it's just not going to run it. It's just going to be like, I don't care what you're talking about. So, and where are these semantics we're talking about? Are probably just going to be on the compiler. You just set a flag on the compiler, say, I want to compile all this code with ignore semantics. And because my code doesn't have bugs. So just shut off all these checks, all right? We can do observe, which is like, yeah, I want to check the condition. And if it fails, if the condition is false, then I want to call this one and only handler. And maybe the handler just logs. And then I just want to keep going. Because actually, this is old code that's been running for years and years. I'm just starting to add contracts to it. But like, maybe this fails, but it returns 17, and somehow that's okay, right? And it's like, I don't want to stop. Like, no one's complained about this code, so I just want to see if anything's odd. I don't want to affect anything because customers are happy. So I can just say, observe, log that you detected an error, but do whatever you're doing. Even if that was undefined behavior, you're going off the end of the vector, I guess that's okay because, no one's complaining about it. Hopefully it continues to be okay until we fix the real bug, right? There's a thing called quick enforce, which is not quicken from Highlander. Quick enforce, which evaluates it and says, screw you, I'm not calling your handler. I am getting out of here. And that's a nice option that the compiler people really wanted to be like, I don't trust your handler stuff. I want to be secure and just have a hardened version of the code base. It's just like, we terminate. And enforce is like, you do everything. You evaluate the condition. If it's false, you call the handler. And then when the handler's done, you quit, right? Except for the asterisks. Oh, well, no, first let's look at an example. Here's one. You got static int g, you know. You have a condition that g is greater than 0, and for some crazy reason maybe you're counting how often you're, checking these conditions. It's like you increment g and say it better be greater than 0. So what happens? Like, what does this actually do? Well, if it's ignore, it does nothing. G doesn't get incremented. If it's any of the other ones that have evaluation, which is all the rest, then G is probably incremented. G is maybe incremented a lot, like more than once every time you call a function. You might get evaluated 2, 3 times every time you call the function. That's allowed. G is maybe never incremented, even though it's evaluating the expression. Because maybe no other piece of code ever decrements or decreases G, and the compiler looks at it and goes, this is always true. It starts out, it's a static, it starts out at 0, it never gets decremented. I don't have to run that code. I've proved to myself that this condition is always true, so I won't evaluate it. And anytime that, for any reason that the compiler can figure out this is guaranteed true, doesn't have to evaluate it. So these are the options. Also, why are you modifying a value inside this precondition that may or may not get called, might get called way more than you expected? Like, why are you trying to increment G? The good news is you can't increment G. Well, you can because it's C++, but you have to const cast it, right? So we're trying really hard to just, it's the pit of success, right? It's like, you try to do the wrong thing, it's like, no. You have to work extra hard to do the wrong thing. And now the asterisk. Terminate means contract terminate. I'm not saying standard terminate because it didn't fit. Contract terminate could be terminate. It could be standard abort. It could just like stop, like not call anything else. Just like, we're done. We are out of here. It's whatever the implementation wants contract terminate to mean, but it does mean terminate. It's not going to keep going. And enforce with the, enforce after you called your handler, it's going to call terminate, the contract terminate, unless your handler threw an exception. So then the handler doesn't like flow out the normal path, so it doesn't call the terminate, and you actually get back to your function and you go out of your function with your exception. Do you want to do that? Probably not. Some people say definitely not. Come on. I got it. Yeah, there it is. It depends, right? So because it's C++ and people just do whatever in this language, we don't try to limit you too much. The goal is we push you towards the pit of success. You probably don't want to modify variables. You probably don't want to do this. You fall into this pit of success. But hey, if you want to do something else, you can do that other thing. We don't want to stop you from doing stupid things because sometimes stupid things are the best thing to do. Like I've written some crazy code. Wrote some code where I had to describe it to somebody. It's like, the constructor, blah, blah, blah. And then like it long jumps, blah, blah, blah. Then the second time out of the constructor, like the second time out of the same constructor, I'm like, yeah, the second time out of the constructor. Yeah, we didn't ship that code. It was considered, someone wanted to know how to do something. I'm like, you can't do this. And I was like, wait a second, you could do it, but you shouldn't do it. So, should I check for null here? No. No. You should check for null here. Wait, why not both? But why? Why would anybody want to? Oh, I don't even want to talk about Hiram's Law yet. Oh, I said to myself, why not both? I think I wrote no notes. I should just know why not both. So, I've a number of places. One was at BlackBerry, I wrote APIs. Almost every place I've written either like internal library APIs or libraries that you are going to call. Someday I'm going to do a talk called the BlackBerry C++ APIs. The best APIs you will never use. They were beautiful, beautiful APIs. No one called them. But I was in charge of the whole API, like everything had to be consistent, what style we're going to use. It was a thing of beauty. As a library writer, and especially an OS or something like that, I don't want the code crashing in my code. Because every time it happens, I get blamed. And sure, I just don't want to be blamed for stuff, but it's a waste of both of our times. You know, like someone sees it's like, oh, it crashed in, some function. That's your code. I'm like, it crashed because you passed me null. The documentation says null. It's so clearly not my bug. And they're like, oh, we just looked at the crash and it says, the call stack is your function. Fix it, right? And like, go and explain it to people. And I just don't want that. So even if I put in a contract in at the top that says, it's your fault if you give me null, I should not have to check for it. It's so obviously your fault. I might still check for null because you're going to shut off contracts, right? And I just don't want to be blamed for when it's null. Now, what am I going to do in that, if it's null? That is going to be load-bearing code. I'm just going to do something to not be my fault, and then you're going to rely on it, right? And the Facebook app at BlackBerry back in the Java days, we couldn't change internal data structures because Facebook would not work anymore. And it was like, oh, you can't break Facebook. I'm like, they're reading our internal data, like our internal objects. Like we should be able to change the order of our objects. Don't touch it. It's load-bearing code, right? So it depends, right? That really is the answer. I just had to mention that last part because there's people on the committee who are arguing strongly of no, I'm still going to check afterwards. I'm like, okay, we allow, just do whatever you want. Questions?
That was an
Let me answer it.
That was an interesting example of null being a bug. You try to handle a bug, and then suddenly null becomes not a bug. It's like this: the road to hell is paved with good intentions.
Yeah.
Do you have any other examples in your experience of you try to do the right thing, and then it creates a culture where then it becomes okay to do the wrong thing?
Oh, I probably do. Yeah, I've got 30-something years of experience. My description in the schedule still says I've been coding over 25 years because I think if I keep upping the number at some point, I'm like, I don't listen to this guy. He's got he's ancient. So it's over 25 years, 35. Can I think of any though? Definitely everything that I write that I think, oh, this really solves a problem. I wrote a thing called any pointer, any smart pointer, any tidy pointer, right? And it's just it's literally unique pointer with a standard function for the deleter, right? So then you can just, is this thing, I don't care. I just need, you're going to give me this pointer. I'm going to use it. I'm going to throw it away. Or I'm going to pass it along. It was move only because it's unique pointer. But underneath it might have been a shared pointer inside somewhere. And it's just, I don't care. I'll just clean up. Or the pointer will clean up after it. That's all I care about. I don't care how. I don't care which one. It was a great, I have an image class, which is one of my favorite classes that I've ever written. a move-only image class. I'm very proud of it. It holds data, right? Holds the pixels. And I'm like, well, sometimes it almost always owns the pixels. And this is another like it depends trade-off. It should own the pixels. But then there's like once in a blue moon, it's like, I just want to wrap your pixels into my image class, do some processing because everything takes my image class, and then let go. And I never copied any because it's like performance wins. You gotta just, and it's like you've broken the whole security, not the security, but the whole, safety blanket of this image class that was move only because it always owned the value and you would never have two people. And it's like, yeah, I know, but I need the performance. So, and it's the same thing, pit of success. It was hard to construct that, right? But I'm like so far tangential. It was hard to construct that thing, but it was allowed. And internally, I needed an any tidy pointer. It's like, usually I own this pointer. Sometimes it comes from somewhere else. I don't care. I just need to know that I'll do the right thing at the end. And then any tidy pointer got scattered throughout our code. It's just like, oh, this is the answer for everything. We'll just use it here and we'll use it here. And I'm like, just use a reference. Like you don't need a pointer at all. Like you wanted a reference here. It's like, yeah, but I already had a pointer and it just, it was such a nice little class. Yeah, that happens all the time. And people see a pattern and they just keep applying the pattern. It's like, oh, look, I used the callback here because that was, it was kind of a twisted situation. The best thing to use was the callback. And then there's 50 callbacks in the code base. It's like, we don't need, callbacks that, when you need to know the number of items, call this function, it'll tell you. Just pass in the number of items. I don't know. I'm really going off on tangent. More questions? Yes.
Remember the code example where you had a function returning int and you were wondering what you should return in an error case? I have a suggestion. You could change the function's return type from int to pointer to int. And if you got a null, you can always return null and make it all of your callers' problems to deal with it. And if you have lots of callers, like maybe they can be inconsistent about it, it's going to be great.
Yeah, it is. I shouldn't give away that I can give it away now because, well, shoot, yeah, this is a philosophical question. You guys are like, what is he talking about? It's like 3 half sentences. I worked at Christie until very recent. Did I mention that? And we interviewed co-ops all the time, constantly interviewing co-ops. And it's the best interview setup I just perfected the interview set of it. But part of it is like, here's a math problem. Solve this math problem. Just calculate, the end of this math problem is calculate this point, right? And it relates to what we did with projectors and cameras. It's very good. We do a lot of math. I want to know if you can, it's not hard math. It's like grade 12 math. You're in university. Do you remember trig? Calculate this point. And I was like, and the first thing is they look at you funny. I'm like, yes, this is not a programming question. It's a math question, right? They do the math. I was like, great. Could you turn that into a function? Suddenly it's a programming question. And they're and the best part is they have to decide which parameters, it was a problem. Which of these things do you want to make variables? Which of these things do you want to assume? How do you turn this math into code? Somewhere I'm going to get to what you're saying. Somewhere along the lines, they realize, I'll be like, how do you test this, right? And then at some place, they'll eventually realize, oh my God, sometimes I can't return a point. There's no answer sometimes. And I'm like, what are you going to do? And one of the options is, they always say, I could return a pointer to a point. And I'm like, you could. But the best part is, I really like it when they give you a couple of good answers. They're like, oh, I could, and sometimes I give you 0, 0. Is that well, that might be valid, or maybe, one of these, just pick a value. Nan is actually not terrible. It's there's not a point here. And they come up with some good answers. But then I'm like, give me some bad answers. Just keep giving, if I just said, I don't like someone will say, throw an exception. I'm like, I am okay with exceptions, but some people don't like them. Give me another answer. Oh, I could do this. Oh, I can make it a input parameter with a return value error code. I'm like, you could. Give me even worse. And eventually, I could return a pointer to a point. I'm like, yeah, that's really bad. I really like it. But then I get to talk about optional and expected. I'm like, hey, did you know I'm on the committee? I helped with those. Yeah. They're like, you're on the committee? That's how we get co-ops. Okay, that's all we got time for. Thank you.